This is Thresholds, nonprofit, independent, and listener-funded. Support the show at thresholdpodcast.org.
Okay, I'm looking at the Smethwick engine. I guess it's the oldest working steam engine in the world. I'm in a science museum called Think Tank in Birmingham, England, standing in front of a steam engine designed by James Watt in the late 1700s. And when I say engine, if you picture the thing that you look at when you open the hood of your car, wipe that image out of your mind. This is like, it takes up at least 3 floors of this museum. It extends down below, and then it extends high above me. It's a big, hulking piece of equipment with iron rods and pipes and a thick wooden beam on top, rocking back and forth like a seesaw. But I didn't really come here to study the engineering. I just wanted to meet this thing face to face and grapple with what it means. Because the Watt steam engine is often credited with launching the Industrial Revolution. And the Industrial Revolution launched the climate crisis.
It all started in 1763. The young Scottish engineer James Watt realised that the steam engines then in use could be improved by adding a separate condenser. This made the engine far more efficient and powerful.
Welcome to Threshold. I'm Amy Martin, and this is the 3rd episode of our season called Time to 1.5. We're investigating what we're doing and not doing with the time before temperatures rise 1.5 degrees Celsius over pre-industrial levels. And it's the last part of that sentence, pre-industrial levels, that led me here. Britain was the first place in the world to go through what we now call the Industrial Revolution, a transformation of an agricultural, rural society into a manufacturing powerhouse. And this is also where we get our first archetypal images of industrial damage, skies full of soot, children laboring in factories. One of the key concepts of the Industrial Revolution is acceleration. It was a massive speeding up of almost everything: urbanization, mechanization, transportation, production, trade, consumption. And all of those surges were fueled by a radical acceleration of the carbon cycle. The processes that began here in Britain in the 1700s kicked off a multi-century fossil fuel binge, which is now knocking the climate out of whack. So the Industrial Revolution is when we started to move fast and break things, including the delicate carbon balance that has stabilized our climate for 10,000 years or more, as we learned in our first episode.
So we have already crashed through the warmest temperature on Earth since we left the last ice age. We've already gone through.
But this revolution also led to unprecedented levels of personal comfort and ease. If you like getting clean water from a tap, flipping a switch and having the lights come on, heating your house, driving a car, eating food from around the world, using a toilet, or taking a hot shower, you have the Industrial Revolution to thank. You can also give it credit for antibiotics, vaccines, and much longer lifespans. And all of this is an ongoing process. Although we refer to the Industrial Revolution with the definite article in singular form, it's happened over and over in place after place, and there are countless new industrial hubs about to emerge or already on their way: Vietnam, Kenya, Indonesia. This revolution continues to sweep around the planet, bringing both prosperity and destruction in its wake. This is the central conundrum of our time. The Industrial Revolution sped up our ability to meet our needs and fulfill our desires, but it also sped up the ruination of our planet. So how can we stop doing something that feels like advancement? And how do we not stop doing something that's killing us? That's the dilemma we're grappling with in this episode and throughout this season, really. To get started, we're going to home in on 2 key developments in the very early days of the Industrial Revolution that set us on this paradoxical path, to see if there's anything in those stories that could help us set a new course now.
This is the thing, isn't it, with the Industrial Revolution? It's the speed at which it takes off and the exponential increase in the need for everything.
A lot of these industrial towns would be dirty and filthy and smelly.
We know we're modifying the atmosphere in a way that's detrimental for all living species.
We need to get emissions to zero now, otherwise things are going to be much worse.
This village is like the definition of cute. Charming, really, more than cute. I'm walking through the village of Ironbridge, England now, about an hour away from Birmingham. There's a lovely church up on the hill in front of me. The River Severn is flowing along next to the brick sidewalk. It's all very English, complete with a fish and chips place and something called Ellie's world-famous hand-raised pork pies. As I come around a bend, I can see the structure that gives this place its name, a beautiful iron bridge arching over the river, the world's first major bridge made of cast iron. It's just one of many artifacts in this valley from the very early days of the Industrial Revolution.
How are you doing?
I'm doing well. How are you? Nice to meet you.
As I walk up onto the bridge, I meet my guide for the day, Dr. Matt Thompson. He's the head collections curator for English Heritage, an organization that stewards hundreds of historical sites. And although a lot of stories about the birth of the Industrial Revolution start where I started a few minutes ago, in big manufacturing cities like Birmingham, Matt says if we really want to understand how this process kicked off, a better place to start is here, in this verdant little valley, in the early 1700s.
Yeah, often I think we have a very tight historical understanding of the Industrial Revolution and the aftermath. 1760 to 1830 is the kind of real flourishing of it. Whereas I would argue that in reality we're looking at a story that begins much, much earlier, and this place I think embodies that narrative.
It's a bright September day, and our view from the bridge is much more Jane Austen than Charles Dickens.
We're looking at a steep-sided gorge, and it's very, very wooded now. It's kind of like almost a sort of pastoral, it's kind of like a bucolic idyll, you know? Mm. But this really is the kind of heart of industry and the sort of cradle of the Industrial Revolution, although it might not look like it right now.
It doesn't look like it right now. So I asked Matt what this valley would have looked like when it was in its industrial heyday.
What you would have seen in the 18th century would have been a lot of masts.
Masts from the many boats moving goods up and down the River Severn.
All up along here where the warehouse is, they could be 2 deep, kind of moored up there. There would have been chimneys, there was a lead smelter down there was a cannon being cast, there were furnaces and foundries. There would have been smoke, there would have been smell. The river itself was kind of polluted, glassy, stained waters. It would have been a very, very different prospect.
The heart of all this activity was ironworking. There's a lot of iron ore in the land nearby, and Matt says people in this area had been mining it and using it to make all kinds of products for hundreds of years, long before the Industrial Revolution began. But in the early 1700s, a man named Abraham Darby arrived here with an idea for how to change the iron-making process. And Matt says we can draw a direct line from his innovation to our current climate crisis. It all went down just a few miles away from where we're standing, so we head to Matt's car to go check it out.
I'm on the wrong side.
He gently points out to me that I'm getting into his car on the wrong side, because we're in Britain.
Sorry.
And we're off.
And this is a little side valley that we're going to go up now, called Coalbrookdale, and the whole area was called Coalbrookdale, in going back into sort of medieval times.
And a dale is a valley.
Yes, I think that's fair. Yeah.
As we drive up the valley, we pass by old buildings connected by small paths leading through the woods.
So this is where it all happened, like in the 18th and 19th century. This is where the base of operations was of the Coalbrookdale foundry. This big, innovative industrial complex.
Matt says this whole hillside was peppered with places where people worked turning raw iron into finished products. Cannons and cannonballs, horseshoes and nails, pots and kettles. It was a multi-step process, he says.
You start at the top with big lumpy stuff, and it becomes more refined, right? So you have raw kind of iron, as it were, ingots or pig iron, what have you, at the top. And as you go down several different stops down the valley, you end up with a more finished product, until at the end of it, you're at the river with a finished product in a warehouse, put it on a vessel and take it down the river.
The River Severn, flowing along below, is a key character in the Coalbrookdale story. It's the longest river in Great Britain. It starts in Wales, makes a backward sea through western England, and eventually spills out into the ocean at Bristol, connecting this valley to the rest of the world. Matt says the river, the iron ore, and even the shape of the valley itself are part of what led to this place becoming so important in the history of the Industrial Revolution.
Here you can almost see the kind of valley, the dale, as a kind of machine of itself, with component parts being all of these different establishments and installations along the length of it. But the whole thing works with water, gravity, and the raw materials. You know, it all comes together. Quite sophisticated stuff, really. Quite sophisticated stuff.
We arrive at what today looks like a sort of park. There's a museum on one side and a large grassy area with a big iron fountain in the middle. The skies are blue, the hills around us are full of trees, and the only sound is from other visitors quietly walking about. But Matt says for hundreds of years, this place would have been a hive of industrial activity. Hard labor, hot smoke, the constant clatter of wagons coming and going. We head to the far end of the site where a series of old brick walls encloses the space. The thing that Matt is most excited to show me is a crumbling structure in the middle, maybe 20 feet high, now protected under a glass shelter. It's called a blast furnace, and this is actually the first of several blast furnaces we're going to meet in this season of our show, so I'm going to take a minute to describe what they are and how they work. You can think of a blast furnace sort of like a presto changeo machine, a tool for turning metals mined out of the earth into hot liquids, which can then be molded and shaped into whatever you want. A soup ladle, say, or a beam for a skyscraper. That process is called smelting. That's what happens inside a blast furnace. It's a chemical process that happens at very high temperatures, and it separates metals like lead and silver and iron from the rocks or ores they're found in naturally. Blast furnaces were first created almost 2,000 years ago in China, and supersized versions of them are still widely used today. But until Abraham Darby came along, most blast furnaces ran on charcoal. And that's a totally different thing than coal, the stuff that we dig out of the ground. Charcoal is made from wood, and you need a whole lot of it to get a blast furnace hot enough to smelt iron. So in Darby's day, making things out of iron meant chopping down a lot of trees.
In the early 17th century, there's complaints, writers talking about how terrible it is that the trees are all being cut down in Kent to feed the wheeled iron industry, you know? So people are really aware of this idea of deforestation, you know, for industrial purposes, even like 400 years ago.
Enter Abraham Darby. He arrives here in Coalbrookdale in the early 1700s, aiming to make a living producing iron. A lot of other people are doing the same thing, which means there's a lot of pressure on the local woodlands. But Abraham has an idea. He's going to run his blast furnace on coal.
Probably the biggest single innovation to my mind would be the fact that Abraham Darby the First, when he arrives here in the very early 1700s, he comes up with a commercially viable way of using coal in the production of iron.
Coal from the ground, not charcoal.
Coal from the ground. People have been doing it before. People had experimented for quite some time, but it always been a challenge to make it commercially viable. Abraham Darby did manage that. He got the recipe right, basically.
And he did so right here in 1709. He started by roasting the coal, which drives off impurities and concentrates it into a form called coke.
And you use coke instead of charcoal. There's loads of advantages. First one is there's loads of coal in the ground here, right?
Abraham Darby didn't invent or discover coke. What he did was figure out how to use it in a blast furnace for industrial purposes.
People knew you could make it, but what he did is he put that little bit extra in that just tipped it over So whereas previously it was experiments, there were always experiments, whereas now there was a marketable product, you know, he could do it, It was cheaper, it was easier, it was here, it was on site.
Matt and I walk into the shelter protecting the structure and up a set of stairs to a platform where we can look right down into the big gaping hole at the top.
So you can see the furnace here. So this is where the magic would happen, right? This is where and it is magic, isn't it? You're taking things that are literally dug out of the hills, just over there, and then you turn it into something like that incredible cast iron fountain there, you know. So you're going from rocks to that.
To art, essentially.
And there is a magic in that, you know.
And by switching fuels from wood to coal, Darby was able to make that magic happen faster and more efficiently.
And it took quite a while for other people to adopt it, but then of course in the end everybody did it. No one was going to make, you know, it's like archaic using charcoal.
Cookpots were one of the main products to come out of this ironworks in the early days, and they're a good example of the process of acceleration that defines the Industrial Revolution. Before Darby, cookpots were usually imported from other parts of Europe, which made them very expensive. But using his new coal-fueled process, Darby was soon able to create high-quality cookpots faster and more cheaply than his competitors, making them affordable for a whole new group of people. And as more people got them, more people wanted them, which required more iron and more coal.
You know, you hardly need a picture drawing, do you? Where does that line go for the use of coal in industry, you know?
If you do need a picture drawing, look up the Keeling curve. That's the steadily upward trending line tracking the amount of carbon dioxide in our atmosphere. Before we started burning fossil fuels on a mass scale, the Earth had about 280 parts per million CO2 in the air. In 2021, we had around 416 parts per million. And the difference between those two numbers, 280 and 416, is us. Our cars and air conditioners and furnaces and our industrial processes.
Large-scale industrial use of mineral fuel, I mean, you absolutely can put that here. That's the legacy.
Abraham Darby's world might seem very far away now, but his technology is still with us. The process has been tweaked, but we are still concentrating coal into coke and burning it in blast furnaces, especially in the production of steel. And the emissions produced by Darby's furnace and every one of its successors are still with us too, because once carbon is released into the air in the form of carbon dioxide, it sticks around for 300 to 1,000 years. There's no single moment when the countdown to 1.5 degrees of global heating began, but if I was forced to choose, Coalbrookdale in 1709 would be a top contender. Once Darby figured out how to use coal to smelt iron, it was a short leap to doing the same thing with lead, and silver, and tin, and copper.
Once it's caught on, then of course, coal becomes the fuel, and then you see an exponential increase really in the amount of use.
And an exponential increase in the need for everything else in the production process.
So that's not just kind of materials and fuel, it's also what it needs in terms of people, human resource, human capital. That goes through the roof. This is the thing, isn't it, with the Industrial Revolution? It's the speed at which it takes off and the exponential increase in the need for everything. In the same way as you see the shift almost within a generation, of people living in small rural settlements or market towns, and then this incredible explosion of cities in terrible conditions, and you see a rural population suddenly within what we would kind of recognize as an urban environment. Huge changes, and kind of that psychologically that must have had an impact. Well, it did have an impact.
And it impacted this little valley too. 3 generations of Darbys kept this furnace burning strong, and their success meant that this area became clogged with coal smoke. Matt says one writer described it this way.
This idea that if a man was to sort of fall asleep and just be transported to the furnaces around here and then wake up, he would think he was waking up in hell. and that all these people working around him were demons, because there were flames and fires everywhere.
Abraham Darby III ran the ironworks in the late 1700s, and it was his idea to build the cast iron bridge as a sort of advertisement for the skill and techniques developed here. And it worked. People came from all over the world to see the bridge and marvel at its beauty and strength. But not everyone came away with the story that the Darbys wanted told. A writer named Anna Seward came to visit and wrote a poem called Coalbrookdale. The second line is,
"Oh, violated Coalbrook." And in it, she pictures industry as the Cyclops. The Cyclops was the assistant of Vulcan at the forge, So Cyclops represents industry, effectively having a sort of battle with all the naiads, dryads, tree spirits, water spirits, fairies, all these sort of stuff of the natural environment. And she talks about the sort of sulphurous air and the glassy, oil-stained waters. She sees a landscape that has been despoiled by industry. In the end, Cyclops wins.
And Cyclops was just getting started. If Anna Seward found the changes at Coalbrookdale worthy of grieving, imagine what she would make of Chernobyl, or just any ordinary industrial city today. Our transformations of this planet are stunning. The physical stuff we have made now weighs more than all living biomass on Earth. It's nearly impossible to find places on land or sea where the noise of our own activity doesn't intrude. And since the Industrial Revolution, hundreds of species of plants and animals have been lost forever, with many more teetering on the brink. According to the International Union for Conservation of Nature, 13% of bird species are at risk of extinction today, 1/4 of the world's mammals, 40% of amphibians. So this is another thing that has accelerated since the Industrial Revolution, the extinction rate. Of course, it would have been impossible to foresee all of this when Abraham Darby started burning coal in this furnace. In fact, as we walk away, Matt tells me early industrial processes were still very much governed by nature. For example, water power. It was essential to the smelting process in the early 1700s. So Darby couldn't have set up his ironworks just anywhere. He needed to be close to the stream that still flows through this site today.
You had to be where the water was, simple as that.
Water told you where you could smelt iron, and also when. Matt says in the late spring and summer, as the rainfall dropped off here, it became harder and harder to keep the furnace going.
They'd let it go out, and they'd maybe carry out repairs, reline it, do this, that, and the other. So over the summer, it would be out of blast. And at that same time, a lot of the people who might have been working in the furnace would perhaps be needed on the harvest, So you can see, this idea of industry actually intimately entwined with the environment that we see around us, including the weather and the seasons,
But all of that was about to change. Soon, the idea of timing industrial processes around the rhythms of the earth would seem old-fashioned, and then be forgotten altogether. And this place would go from being called Coalbrookdale to Ironbridge. Instead of being defined by 3 natural features, coal, brook, and dale, it's now defined by what humans did and made here. We'll have more after this short break. Welcome back to Threshold. I'm Amy Martin, and we're in England for this episode, investigating how the Industrial Revolution, and thus the climate crisis, got started. And we're about to head to Birmingham to explore the story of the inventor James Watt. You've heard of him, even if you don't know it. Remember Back to the Future?
1.21 gigawatts! 1.21 gigawatts! What the hell is a gigawatt?
Yes, James Watt made such an impression on the world that he has a unit of power named after him, the Watt. In just a minute, we're going to talk about why he gets so much credit and maybe some blame for launching the Industrial Revolution. But first, I want to pause here and get a little meta on you. I want to call attention to how I'm telling this story. We started out with Abraham Darby and his blast furnace. Now we're moving to Watt and his steam engine. This is a very familiar template. Individual genius invents new technology that changes our lives. The genius is almost always a man and white, and his invention is almost always framed in a narrative of progress. There are endless examples. Eli Whitney and his cotton gin, Alexander Graham Bell and his telephone, Elon Musk and his Tesla. We tell ourselves this story over and over. These men and their machines made our lives better. No further questions. It's neat and tidy. It goes down as easy as a fairy tale. There are reasons for this narrative, but there are also some very good reasons to question it. So let's just keep our eye on that as we explore the life of the man whose last name is on all of our light bulbs, James Watt.
James Watt was born in 1736 in Greenock in Scotland, and he showed at an early age considerable skill in making things and repairing things.
Dr. Malcolm Dick is the director of the Center for West Midlands History at the University of Birmingham. And he says Watt didn't grow up in poverty, but he wasn't rich either.
Watt seems to have been quite a sickly child, so a lot of his education was at home.
Watt never studied at university, but his mechanical skills allowed him to get a job at one. He worked at the University of Glasgow, about 300 miles north of Birmingham, and his job was to make and repair scientific instruments.
And through that work, he was introduced to a model of an early steam engine, a Newcomen steam engine.
These engines were designed by a man named Thomas Newcomen, and some of their parts were actually manufactured by the Darbys in Coalbrookdale. They were fueled by coal and produced steam power, which was used to pump water out of the bottoms of coal pits so the miners could keep digging. Previously, that water had to be hauled out by hand, so these engines were a big leap forward. But they were also really expensive to run because they consumed massive amounts of coal. James Watt was asked to repair a model of a Newcomen engine at his job at the university, and after studying it, he went on what has become a famous walk through a park in Glasgow in May 1765. That's when he had an idea for a significant improvement in the engine's design.
He developed what was called a separate condenser. In essence, that was a device that prevented the machine cooling down between the beats of the steam engine as it moved up and down. And Watt got really interested in this.
He made a prototype and discovered his design was 3 times more efficient than Newcomen's. For every ton of coal burned in Watt's engine, you could do 3 times as much work. To be clear, Watt wasn't trying to burn less coal because of environmental concerns. He was just trying to make a machine that worked more efficiently, and he succeeded.
Now that brought Watt into the notice of other people,
including members of something called the Lunar Society,
which was a group of individuals who met on the first Monday after the full moon, hence the name Lunar Society, in each other's homes.
This was the Birmingham version of something that was happening in many European cities at the time, the Salon. The physician Erasmus Darwin, grandfather of Charles, was a member, as was Joseph Priestley, a religious dissenter and discoverer of oxygen and 9 other gases. The Lunar Society was a group of inventors and manufacturers, thinkers and political writers, with a keen interest in the natural world and the important topics of the day. They had visits and correspondence with Thomas Jefferson, Benjamin Franklin, and Anna Seward, who wrote the poem about Coalbrookdale.
They were people who were brought up, if you like, in what we call the Enlightenment, and they absorbed many progressive ideas, including the belief that you could improve the world by investing in it and exploiting its resources and manufacturing products. They believed that things were getting better.
And by testing out ideas on each other and helping each other make connections, Malcolm says the Lunar Society played a significant role in the birth of the Industrial Revolution. We're actually talking at the home of one of their most dynamic members, Matthew Bolton.
So we're at Soho House, which is one of the few surviving 18th century buildings in Birmingham.
Bolton was the son of a prosperous Birmingham manufacturing family, and he frequently hosted the Lunar Society here. And Malcolm says the surviving records from Soho House show that Matthew Bolton knew how to throw a party.
They drank port, they drank wine. In fact, Soho House is an extensive cellar, and you can imagine it being filled with all kinds of goodies.
I visited Soho House on a warm, bright afternoon, but as Malcolm and I talked, I was picturing a moonlit night 250 years ago with members of the Lunar Society wandering around these grounds, philosophizing, and maybe discussing the quirky Scotsman named James Watt, who had a clever new design for a steam engine.
Watt and Bolton got to know each other. Bolton was able to offer Watt a partnership.
Watt had an abundance of ideas and technical skills, but to unleash his full potential, he needed things he didn't have: money, manufacturing space, skilled workers, customers for his products. He needed capital and a front man, and he found those things in Matthew Bolton. Watt moved down to Birmingham from Scotland, joined the Lunar Society, and soon the partnership of Bolton and Watt was up and running.
Bolton was the extrovert. He was good at dealing with politicians and aristocrats and selling goods. That was not what Watt was good at. Watt was a different personality. We might say today that he had manic depression. He had moods that went up and down. We often read in his letters about him not being able to do anything. He gets very depressed. Certainly he was devoted to his first wife who died. And that's another reason why he moved down from Scotland, because I think the atmosphere was too difficult for him. And the Lunar Society provided support, and not only from Bolton, but also from Erasmus Darwin, who was a superb doctor in terms of dealing with anxious patients.
So was he Watt's doctor?
He was Watt's doctor.
So here's James Watt, poised on the precipice of becoming a world-famous inventor, one of the prototypes for the genius sparks progress narrative. But he didn't get here alone. In fact, we may never have heard of Watt if it weren't for the people who were propping him up, promoting his endeavors, drawing him out of his workshop and his melancholy and into the world. That's not to take anything away from Watt, it's just to recognize that he needed people who believed in him and supported him, because we all do. Whatever progress humanity can claim has always been a group project.
We shouldn't forget the role of the women in the families. Watt had 2 wives. His first wife was extremely important, I think, in getting him through some initial difficulties. His second wife was extremely well organised and provided an environment of sort of stability where he could get on with his work without being distracted by having to wash the dishes or make food or sweep the floors or manage the servants, more importantly.
So with Watt working away undisturbed on his designs and Bolton providing the money and the marketing savvy, word began to spread. There was a new steam engine that did everything the Newcomen engine could do and more, but using a lot less fuel. Soon, everyone wanted one.
You got hundreds of machines being produced for all kinds of purposes. Initially, the textile industry, the spinning and then weaving, used it.
People started setting up steam engines in all kinds of places they'd never been tried before.
Used in agriculture for threshing corn, for example.
And then they were used in mills to grind the grain into flour.
Steam engines become very common to pump sewage away.
Imagine how transformative that was.
They have a remarkable range of applications.
And perhaps the most remarkable thing of all, was the way Watt's engine broke the bonds tying industry to nature. Or at least, that's what it seemed to do. As Matt Thompson described in Coalbrookdale, early industrial processes were governed by natural processes. They were embedded in specific landscapes. Abraham Darby I could only run his blast furnace if that particular stream was flowing. But Watt's steam engine could be run anytime, night or day, summer or winter, as long as you had coal. This was a radical new concept. Power became portable and constant, and industrial processes began to detach from the rhythms and requirements of the earth. People began to imagine that they could sever themselves from the rules of nature. But there was a catch. Watt's innovation, combined with Darby's and many others, kicked off a mass migration of carbon from under the ground to up in the air. Planet-warming gases that had been locked away in the Earth's crust are now circulating in our atmosphere, knocking the climate that sustains us out of balance. So we actually never did break free from the laws of nature. We've just been temporarily ignoring them. In the mid-1770s, with the American colonies revolting against the British Crown, Boulton and Watt started selling their new steam engines. Later, parts for some of those engines were manufactured by the Darbys in Coalbrookdale. And this is a classic feature of the Industrial Revolution. Different innovations intersect and help each other to grow. One of the great ironies of Watt's story is that his steam engine burned less coal than its predecessor, but that very efficiency made it wildly popular, which led to a huge increase in coal use. When Watt died in 1819, more coal was being burned than ever before.
Well, exactly. It contributes to what we call pollution. Pre-industrial revolution, cities were polluted, but you've got it on a larger scale, and you've got coal being used in manufacturing, and you've got all sort of chemicals being produced from different processes as well, pouring into the atmosphere. So a lot of these industrial towns would be dirty and filthy and smelly.
The air in many places became so polluted that it produced acid rain. Malcolm says the stone walls of some beautiful old cathedrals started to get worn away by the toxic air. And although there were definitely more things for people to buy at a price more people could afford, the process of making those things wasn't pretty.
If we went into a 19th century town or factory, we would see dirt, smoke, a lot of people being injured, probably a lot of people looking sick, women who would be doing a lot of sort of semi-skilled and lowly paid work. We'd probably be quite horrified to see the reality of that. You do have recreated factories, but obviously they don't create everything. They can't necessarily create the sort of atmosphere, the smells, or the injuries people had, or people coming in with infectious diseases, or the brutality that might exist as far as punishments were concerned.
If we want to get a glimpse of the horrors of industrial labor in the absence of protections for workers and the environment, we don't actually have to try to imagine England in the 18th and 19th centuries. All we need to do is look up factory conditions in China or Cambodia right now. Instead of learning from the grim history of early industrial Britain, we seem to keep repeating it. And this takes us back to the notion that the Industrial Revolution was all about progress, led by individual geniuses and their machines. The full story has always been way too messy to fit into that nice, clean narrative. Take the city of Birmingham, sometimes described as the first modern industrial city.
So Birmingham was really an important place. There were links between Birmingham and the wider world. It was already a global city in the 18th century. Its trade extended not just to Europe, but to North America, the Caribbean, Africa. There were links with the slave trade.
Britain had been involved in the slave trade since the 1500s. But as with everything else, the Industrial Revolution accelerated the speed and scale of slavery and its brutality. Malcolm says guns made in Birmingham were sold to people who were enslaving other human beings in Africa. Ironware made in this part of England, maybe even in Coalbrookdale, was also sold to enslavers. Think shackles and chains. But that's really just the surface layer here. The industrialization of Britain and later the United States was utterly intertwined with slavery. Take the iconic British textile trade as just one example. By 1860, almost 90% of the cotton textiles coming out of British factories were made with cotton grown and picked by enslaved people in the U.S. Sugar, tobacco, and other early industries were also made profitable through slavery. So from the very beginning, the Industrial Revolution was never only about progress. It brought both increased comfort and increased misery simultaneously. As we built, we destroyed. As we advanced, we also regressed. Things got better and worse and everything in between all at once. And they still are. The transition from combustion engines to electrical vehicles is happening, and that's a big win for the climate. But some of the cobalt used in those electric vehicles is being mined by people, including children, who are working in horrible conditions in the Democratic Republic of Congo. Clearly, we need to get more electric vehicles on the road as quickly as possible, but if human rights are being abused in order to make that happen, can we call it progress? This is the poisoned apple at the heart of the fairy tale of endless advancement. It celebrates achievement, but doesn't reckon with the costs. It's a story in which some people get to prosper while ignoring how their increased comfort depends on the suffering of other people and the destruction of other places. Not only is this unjust, it's unsustainable. Because eventually there are no other people or other places. There's just us, here, together. So I think what the climate crisis is showing us is that we need a new definition of progress, rooted in the understanding that our advancement is completely bound up with the health of the earth and each other. I'm back in Coalbrookdale, walking alone through the forest that's just behind Abraham Darby's blast furnace. This place, this quiet little natural area, this is as much a part of the Industrial Revolution as the furnace that's just behind me. Everything around me here helped to birth the Industrial Revolution. The woods, the stream, the iron ore, the coal, the river. We tend to edit nature out of this story and focus almost exclusively on our own ingenuity. But actually, everything our species has accomplished has been a collaboration with the natural world. And our continued survival depends on our ability to keep that collaboration going. I think it's worth paying attention to the fact that the so-called Industrial Revolution was really an industrial evolution. And like all forms of evolution, it emerged out of prior forms. And I guess maybe where I'm going, or where I'm arriving, is I think that's actually hopeful. I don't know, it feels to me then like there's much more potential for it to continue to evolve as our human needs and awarenesses evolve. To solve the climate crisis, we don't only need different forms of energy. We need different stories, different guiding myths. We need to revise our concept of what it means for us to advance. Now there's an awareness that we have the potential to do great damage. And I think that awareness can matter if we want it to. What if instead of trying to break the planet's rules, we applied our intelligence toward understanding them and figuring out how to live well within them, together? What if we spent the next 300 years defining progress as something that improves human lives and contributes to the health of the planet? I don't know what that world would look like, but I hope someday somebody gets to find out.
I'm Justine, calling from Concord, New Hampshire. Reporting for this season of Threshold was funded by the Park Foundation, the High Stakes Foundation, the Pleiades Foundation, Newsmatch, the Llewellyn Foundation, Montana Public Radio, and listeners. This work depends on people who believe in it and choose to support it. People like you. Join our community at thresholdpodcast.org.
This episode of Threshold was produced and reported by me, Amy Martin, with help from Nick Mott and Erica Janik. The music for this season of our show is by Todd Sikafus. The rest of the Threshold team is Eva Kalea, Talia Farnsworth, Shola Lawal, Casey Simpson, and Deneen Weisky. Thanks to Sarah Sneath, Sally Deng, Maggie Contreras, Hannah Carey, Dan Carreno, Luca Borghese, Julia Berry, Kara Cromwell, Katie DeFusco, Caroline Kurtz, and Gabby Piamonte. Special thanks to Adam Reed and David Nye.